Hello everyone. Today's topic is about Stokes theorem. I will go through the generalization of Stokes real-world application and a few examples. To understand Stokes theorem, you guys need to know first what Grimm theorem is because there is an interrelation between those theorems. So Grimm's theorem states that given a continuously differentiable two-dimensional vector field F, the integral of the microscopic circulation of F over the region D inside a simple closed curve C is equal to the total circulation of F around C as shown as the equation. The equation shows that the line integral of vector field F is equal to the double integral of microscopic circulation dA. And this actually means that if we are about to calculate the vector field, like we are calculating the line integral of the vector field around this boundary of a surface, we actually can find the circulation inside the surface, which denoted by this red circle. So that means that we just can find the circulation inside a surface just by doing the line integral. That's what Grimm's theorem states. So Stokes theorem generalizes Grimm's theorem in 3D form, which means that the main idea is still the same. We want to calculate the microscopic circulation inside a surface by just calculating the integral of vector field F around a surface. So we can write the equation as integral of S F dot ds equal to double integral of S curve F dot n, which is the normal to the surface ds. And there is 4 steps that we need to follow to do the Stokes theorem. First step is to calculate the curve F, and the second step is to calculate the del z minus f as y, and the third step is to finding the limit of xy plane, and the last step, which we need to do the integral of curve F dot, which means we need to do the dot product of the curve F with del of z minus f as y ds. That's all.
Assalamualaikum. So in this video, I will show you guys how to solve this example 1 using Stokes theorem to evaluate circulation integral, where vector field dot product with dr, where C is the circle, defined by x squared plus y squared equal to 4 in the xy plane, which is z equal to 0, oriented counterclockwise, and vector field equal to negative 1 over 3 y cube I plus 1 over 3 x cube j. So the correct answer, as we can see over here, is 8 pi. So let's prove it. First thing first, we have to find curl for vector field, which is we use the determinant form, this one, and then for I component, we get del over del y0 minus del over del z 1 over 3 x cubed minus j component, which is del over del x0 minus del over del z negative 1 over 3 y cubed plus k component, which is del over del x 1 over 3 x cubed minus del over del y negative 1 over 3 y cubed. And then we simplify it, become like this, which is 0 minus 0i minus 0 minus 0j plus x squared minus negative y squared k. And then we switch it into vector notation, which is this one, 0, 0 x squared plus y squared. But remember that x squared plus y squared is equal to r squared. So we can write it again like this, 0, 0 r squared. Next, the second thing that we have to find is gradient for z minus fxy. So in this question, it is already mentioned earlier that z is equal to 0. So fxy is equal to 0. So we have to find gradient z. So del over del x z is equal to 0. Del over del y z is equal to 0. Del over del z z is equal to 1. So we already get the gradient for z minus fxy, which is in vector notation 0, 0, 1. Next, we need to find limit for r and theta because from dA, we switch it into dr d theta because in this question, we use polar form. So how to find r? From this equation, x squared plus y squared equal to 4, we know that r squared is equal to 4. So r equal to 2. So the limit for r is from 0 to 2. And then the circle in this question is oriented counterclockwise. So this is how the graph looks like. So theta is equal to 0 to 2 pi. Then we plug in all the value that we already got earlier into the formula. So it becomes double integration from 0 to 2 pi, from 0 to 2, 0, 0 r squared in vector notation for curl vector field dot product with 0, 0, 1 in vector notation for gradient z minus fxy rd theta. And then we solve the dot product 0 times 0 equal to 0 plus 0 times 0 equal to 0 plus r square times 1 equal to r square rdr d theta. And then r square times r dr d theta equal to r cube dr d theta. And then we do the first integration respect to r from 0 to 2. We got r power of 4 over 4. And then we just plug in 2 and 0. And then we got 4. And then we do the second integration, which is respect to theta from 0 to 2 pi. And then we got 4 theta. And then we just plug in 2 pi and 0. We got 8 pi. So we already done with the example 1 with correct answer, which is 8 pi.
Next question. The first thing first we need to do is to find coordinate that form the triangle in the plane of x plus 3y plus 2z equal to 5. So how are we going to do it? Well, simple. We set everything into 0 except for one variable. The first one is if you want to find the x, set y to and z equal to 0. And then you x get 5. And then for y, set x and z equal to 0. And then you get y equal to 5 over 3. And the same thing for z, set x and y equal to 0. You get 5 over 2. The next thing that we want to do is plot the triangle in the xyz graph. So here's the graph.
and then just draw the triangle. As you can see at the graph, this triangle. The next thing that we want to do is to find these things. So the next thing you want to do is to find the cross product between these two. So we're gonna do it. Well, the cross product, just make it the matrix like this. So where did I get this xy, yz, and y? Well, I get from this one. So just plot it. So this is how you solve the matrix. The first one, so we close these two, and then this one multiplied by this one minus this by this two, and then you got this one. Same thing with the others. And remember, for the j, you need to minus, because for the second row, it's actually for the first one, it's actually plus, minus, and plus. So after you differentiate all, this is your answer. The next thing is we want to find this. But how are we going to find it? Well, first thing first, we need to know the f x y. So I'm going to do it. Well, actually, this one is actually f x y z. So how are you going to do the f x y only? Okay, it's easy. You need to express z only. So your f x y is minus x over 2 minus 3y over 2 plus 5 over 2. So you need to plug it in back in this one. After you plug in this the shape of it, and you wonder why everything is different, well, because it is z minus fxy. And after that, you need to differentiate it. For before that, rearrange in the term of x, y, and z. After you rearrange it and you differentiate, this the shape of it. You cannot make it in the form of my equation. You need to make it in the form of vector. So after you got these two, just substitute in it. So this is what it looks like. So you wonder why it suddenly turn into this? Well, you need to make it into that shape. So after that, we need to determine the limit for x and y. For y, we need to draw a xy plane. And for that matter, find this line equation. So my line equation is y equal to negative 1 over 3x over 3x plus 5 over 3. So this is upper boundary, the upper limit, this lower limit. And for this one, you can just simplify into 5 minus x over 3. After you have set the limit, just put it back into this one, and then it become like this. You know the cross product, you need to do like this. That's why my 1 over 2 is in front of them. So after that, just differentiate the y first. And this is different differentiation version, and then just put the limit. And this is the simplified version. And after that, you need to differentiate dx. And then this is the differentiate version of dx. And then put the limit inside. And then after we put the limit inside, and just settle it, and then you got 25 over 27, just like that.
Okay, let's jump into the real-life application of Stokes theorem. By using Stokes theorem, we can find turbulence inside a water surface. Let's say when a man jumps into a pool, it can cause the laminar flow of the water to move in chaotical disorder way, and this can cause turbulence. And to calculate the turbulence, we just need the curve f and the normal of the surface, and just by that We can use Stokes theorem to find the turbulent value. That's all.